This is 9.8a of Algebra. So we're now going to look at systems with a linear equation and a quadratic equation. So if you think back, we did systems where we had two linear equations. Okay, and we saw how many times they'd intersect. Either they intersected once, they didn't intersect at all, or they had infinitely many solutions, right, when they were the exact same line. I can't draw that very well, but so we've got that same sort of idea going here. Sorry, let me erase this. We can either have two solutions, one solution, or no solution. So we don't get the case where we have infinitely many solutions like we did in linear. And we didn't have two solutions in linear. But these are the three different ways that we're going to get results. So we are going to look at a couple different ways that we can solve and find our solutions. The first one we're going to look at is about solving by graphing. Okay, so let's do this first one. The way that we've been graphing quadratics is we're making a table, right? So I'm going to make a table of this. Let's do that right here. So I'm going to do x squared. Ooh, we're going to run out of room. Let's move that. Because I'm going to write out every single step just to make sure that I get it right. So I'm going to do an x squared, 2x squared, and 2x squared plus 1. So I'll plug in -2, -1, 0, 1, and 2. Those are always just good starting numbers. -2 squared is a +4. -1 squared is a +1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Then I'm going to take those numbers and I'm going to multiply them by 2. 2 times 4, that's 8. 2 times 1 is 2. 2 times 0 is still 0. 2 times 1 is 2. And 2 times 4 is 8. And then I'm going to add 1 to each of those. So 8 plus 1, that's 9. 2 plus 1, that's 3. 0 plus 1, that's 1. 2 plus 1, that's 3. And 8 plus 1, that's 9. Okay, so I'm going to draw on my axes and graph that. That should give me enough room. So at -2, I go to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. At -1, I go to 3. At 0, I go to 1. At 1, I go to 3. And at 2, I go to 9. I'm going to, roughly connect those. Okay, and then I'm going to graph my linear equation. Okay, hopefully you remember how to graph this. If you don't, and in the panic of the moment you don't know what to do, you can make a table for linear equations as well. But remember, this is our y-intercept, so we start by putting a point there. So I'll put a point at 1, 2, 3, 4, 5. And my slope there is -2, which is the same thing as -2 over 1. So I'm going to go up 2 to the left 1, up 2 to the left 1, and I intersect there. And for my original point, if I go down 2 and to the right 1, hey, I intersect there as well. Just like that. So I've got two solutions. This is 1, 3, and this is -2, 9. So those are my answers, -2, 9, and 1, 3. Okay, and then let's do our other problem there as well. Something that looks different than what we've done before is graphing this. I'd suggest you do it all at once. If you need to break it up, you can. Your choice. I'm going to do that down here. So I'm going to have x, and then I'm going to plug into x squared plus x plus 3. So I'm going to start by plugging in -2. I'm going to leave myself more room. I'm not going to plug in all my numbers yet. So -2 squared plus -2 plus 3. Well, that turns into -2 squared is 4. So this is 4 plus a -2 plus 3. So 4 plus -2, that's 2, plus 3, that's 5. And I'll plug in negative 1. Negative 1 squared plus negative 1 plus 3. That's not negative 1, a positive 1, right? Negative 1 squared is a positive 1. So 1 plus negative 1 plus 3. Well, 1 plus negative 1, that's just 0. 0 plus 3 is 3. Plug in 0. 0 squared plus 0 plus 3. That's just 0 plus 0 plus 3. So that's 3. Don't freak out, okay? You might look at that and say, crap, I got 2 3s in a row. That's not a problem. All that means is that the vertex is somewhere in between here. It's not actually going to show up as one of our points. Plug in 1, so we get 1 squared plus 1 plus 3. So that's 1 plus 1 plus 3. 1 plus 1 is 2. 2 plus 3 is 5. And we'll do 2 as well. 2 squared plus 2 plus 3. That's 4 plus 2 plus 3. 4 plus 2 is 6, plus 3 is 9. Okay, so I'll draw myself a graph. And graph those points. So at negative 2 I go to 5. At negative 1 I go to 3. At 0 I go to 3. At 1 I go to 5. And we said at 2 I go to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm going to connect that. That's my parabola. I'm just going to estimate where my vertex is. I realize that's not super exact. And then I need to graph my linear equation. If it doesn't have a y-intercept written there, it's just plus 0, right? You can add 0 and that won't change it. So our y-intercept is at 0. And my slope is a negative 1, so that's negative 1 over 1. So I'm going to go up 1 to the left 1, up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. And you can see that these aren't going to intersect, right? So there's no solution. So graphing was one method that we could do. Now we're going to try using elimination. If you think of the word elimination, you think of the word get rid of or cancel out. So that's what we're going to do. And again, if you can think back to when we did linear systems of equations and solving those, we did one way was graphing. Another way we did was elimination. So we're doing the same methods. It's just this time with a linear equation and a quadratic equation. So we're going to do our problem here, and we have two equations. Y equals 36x plus 54, and y is equal to negative x squared plus 39x plus 64. So we need to rewrite these and line them up, okay? There's different advantages for which one you put on top, and I'll try to explain those. So y equals, I'm going to first try putting the one with the x squared up top. So negative x squared plus 39x plus 64. And then beneath it, I don't have an x squared, so I don't write anything there. I've got 36x plus 54. So what I'm going to do is I'm going to subtract all of this, and I'm going to get rid of my y is what I'm going to do. That's the thing that I'm always going to be eliminating. Okay, so I'm going to rewrite this because I need to distribute in that negative, or subtraction sign, however you want to think about it. So it's going to be a negative y equals negative 36x, right? It was positive before, so now I make it negative, and minus 54. So now I can add them. So y minus y, that's 0. Nothing subtracting here, so this is just a negative x squared. 39x minus 36x, that gives me 3x. And 64 minus 54, that gives me 10. And then I'm going to factor and solve this, okay? To be able to factor this, though, we know how to factor when the coefficient is 1 out front. Right now it's a negative 1. So I need to pull out a negative out of all of this. So that leaves me with x squared minus 3x minus 10. When you pull out a negative, all that's changing is if it was positive, now it's negative. If it was negative, now it's positive. Okay? And then I'm going to be able to factor this stuff in parentheses. I want to show you what would have happened if I had put the 36x on top. Okay? So if I had y equals 36x plus 54, and on the bottom we put quadratic, right? And we said we'd subtract it, so then if I rewrite it, the top stuff stays the same. Negative y is equal to, this turns into a positive x squared, a negative 39x, and a negative 64. And then if we add them, y minus y, that's 0. Nothing combines with this guy, so he's still x squared. This is a negative 3x, and this is a negative 10. This is exactly the same as this. Sorry, not with the negative, the stuff that's in parentheses there. Okay, you're going to end up factoring the same thing. Okay, so it just matters which one you prefer. If you really hate pulling out a negative, if your x squared is already positive, start with it on the top. If it's negative, start with it on the bottom. The major point is either way you're going to get the same thing, okay? Your process is going to look a little different, and the numbers you're going to work with might look a little bit different, but you'll be okay. So I need to factor this guy. So I'm looking for numbers that are multiplying to negative 10. So remember, when this number is negative, that's when we make two columns. So negative 1 and 10, negative 2 and 5, positive 1 and negative 10, positive 2 and negative 5. And we need to know which one adds to negative 3, and that'd be this pair. So 0 is equal to negative. We get x plus 2 and x minus 5. The negative out front isn't going to make a difference, okay? We're going to use the zero product property here. If you think, let's say this was 0 and this was 5, okay? This is technically a negative 1 out front, right? Actually, let's make that second thing like 100, right? Negative 1 times 0 times 100 is 0, right? If you switch the order, negative 1 times 1,000 times 0, it's still 0, right? Anything times 0 is going to be 0, so that negative out front really doesn't matter. So you're basically ignoring it. So I'll set up my two equations. X plus 2 is equal to 0. X minus 5 is equal to 0. Minus 2, we get that x is equal to negative 2. Plus 5, we get that x is equal to 5. Not quite done yet, okay? Our answer needs to be a point. It needs to be an x value and a y value. So we're going to plug these back into our equation. I personally always go for the linear equation because I think it's less work to figure out. So y is equal to 36 times negative 2 plus 54. 36 times negative 2 is negative 72 plus 54. And negative 72 plus 54 gives us negative 18. So this is the point, negative 2, negative 18. Oops, that's one of our solutions. And I'll do the same thing on the other side. Y equals 36 times 5 plus 54. So y is equal to 36 times 5 is 180. And when we add the 54, we get that y is equal to 234. So we get the 5, 234, and that's our other solution. If we were paying attention to the story problem, we're looking for days where the attendance was the same, so it wouldn't make sense to have negative days and a negative attendance, right? So technically your answer would only be the 5, 234. If this was a regular problem not related to a story problem, both of these would be your answer. And there's your homework.